Hello, and what we're going to do today is we're going to do 7C. This is Oceanography 7C. First thing I'd like to do is apologize because when you get to college, you can take a whole course on ENSO, or the El Niño-Southern Oscillation, and I'm going to do it in about 8 slides. So I'm just going to be touching the process. I have a video down here about understanding ENSO, which I'm not going to show because it'll be a copyright thing, but I'll put the URL underneath this video and you can get it, as well as some of the other things that are there. But basically what ENSO is, it's an irregular shift in the ocean and atmospheric characteristics. So the ocean temperatures change and the atmospheric characteristics change, and it does this anywhere between 2 and 10 years. So it can happen very frequently, or it may actually be like once a decade. It affects the global climate. It actually will make some places warmer, some places colder, some places wetter, some places more dry, and it'll actually not affect some other areas. It is cause harmful and beneficial consequences. It can actually shut down food webs. It may actually give dry areas more beneficial rainfall, could actually give very wet areas less rainfall, but basically the big thing is that it's a harmful and non-beneficial consequence for most places on the planet because it's an atypical weather situation. There is an ENSO tracker, and back on the 12th of May 2015, it actually swung from neutral all the way to ENSO. Basically, what we have is we got a neutral condition, so ENSO will go back to neutral, then it'll go back to La Nina, which is the other end. This is the warm event, this is the cooler event, this is the normal event. And we'll talk about both these extremes, the La Nina and the El Nino, in this section. Normal situation, we actually set up with a low pressure over here in the western part of the Pacific and a high pressure here in the eastern Pacific. And what it does, it causes this convection cell. And this convection actually pushes the air away from the coastline here in the Americas, which drags the water and makes a relatively strong normal trade wind. And it actually pulls cold water up, which is called upwelling, and actually brings the warm water and concentrates it on the west coast of the Pacific, or over here in Indonesia above Australia. Causes lots of rain there. It is a rainforest, gives Australia some rain, and it actually keeps this relatively dry, and these are desert type areas. The El Nino event actually weakens this whole process, and what we do is we get the convection actually bringing the rain here, and we also get some more rain in the Americas, and what it actually does is it drags warm water across the ocean because the trade winds weaken, and this warm water blob goes this direction, bringing cold water up here, which actually causes them a much drier environment. And what it does for here is it shuts off a food web. Cold water brings oxygen or nutrients up to the surface. Warm water gets decimated very quickly, and then pretty soon the oxygen levels drop and the nutrient levels drop. And basically what happens is it shuts down food webs. The La Nina is this normal event gone crazy, and we get much stronger trade winds, brings much colder water up, very good for marine life, and then maybe not so much for Australia or Indonesia because of the increased convection, increased condensation, increased storms, much more prevalent in this area during a La Nina event. Most obvious, it's in the Equatorial Pacific. It actually happens right along here. It does affect the Indian Ocean as well, and you'll see that if you watch that video on the Australian meteorological events. Warm pool of water moves eastward across the Pacific, runs into the Americas. It changes the pattern of upwelling and downwelling. The upwelling ceases, and we actually get what's called downwelling, which is not good because, again, that's depleted oxygen, depleted nutrients running into the Americas here shuts down the food web. The warm phase of the ENSO is actually called the El Nino. And the El Nino actually, like I said, is warmer water, higher sea level. So it brings warmer water up towards the surface, blows it across the surface of the ocean. Warm water is less upwelling, lower biological productivity. Warm seawater kills some marine life, usually it's the young, and that can be birds and seals as well as fish. And it's a shift in the atmospheric pressure. You notice we have low pressure here and high pressure here. Well, now we actually have high pressure here and low pressure as well as low pressure here. So it shifts the pressure, and basically what it does, it shuts down this convection cell, which normally brings the cool water, and actually now allows weaker trade winds and allows the warmer water to move across the Atlantic. And you can see the difference in the profiles. Nice cold water most of the Pacific coast, Pacific surface, and this one actually is much warmer. It's a shift also in the precipitation. So instead of the precipitation actually happening here where we expect it, it actually happens in the middle of the ocean and a weaker amount over here in the Americas. So it shifts it from one coast to the other. Here's a picture from January 14th, 2016, just a few days ago. And here is that warm body of water, and you can take a look at it, and it looks like it's 3 to 5 degrees warmer than normal. And we have the cooler water sitting over here where we normally expect the warmer water, and we actually do have a relatively warm Indian Ocean, but it's only 1 to 2 degrees, and then much colder water down here. Even all down to about the exact amount of what this is above, this amount below. But this is an El Nino warm event, or an ENSO warm event called an El Nino. Zooming in a little bit towards the Americas, you can see that nice warm water coming up here. This is the Galapagos Islands, but basically what it does, it shuts down that food web, knocks down the oxygen and the nutrients, so the plankton die, the little fish die. Bigger fish can maybe swim out of the way. Seal pups don't get fed. Mom's milk shuts down. Mom can actually swim away. The seals usually can't. Same with baby birds and nests. Shuts down quite a bit. And this is an operational SST anomaly chart. And you can click this link. And again, I will put that down in the comment of this video. And you can actually go and take a look at different dates and watch. Hopefully this El Nino shut down. Here is all three of them. Here's the alert, and we take a look at it, and you can see this one looks more blue, this one looks more red. So this is the normal condition. So our dial would be here in the neutral area. This is the La Nina, so it would be over in this direction with a normal event gone crazy, much colder water, which again is good for biological life, maybe not so much for people and weather. And then this is the El Nino, where we actually get this warm water moving all the way across. So that's the difference between the SST, the sea surface temperature, which is all satellite driven. The La Nina ENSO, which is the cool phase, much stronger trade winds. So the trade winds which are blowing this cold water away from the Americas goes crazy, blows even more. Warm pool stays in the western Pacific, maybe intensifies, increase upwelling in the eastern Pacific. Shift in precipitation patterns, not so much a shift, but an exponential increase in dry on this side and wet on this side. And you can see here's the upwelling. It actually pulls much more cold water up to the surface and then blows it across the Pacific Ocean. ENSO data collection. We have a lot of satellites. We have TOGA, the Tropical Ocean Global Atmosphere, TIO, which is the Tropic Atmospheric Ocean, which monitors ocean temperature as well as atmospheric conditions. It also indicates what phase of the ENSO we're in, whether it's La Nina, neutral, or the El Nino. Okay, the Pacific Decal Oscillation, which is basically talking about 10 years, decade-long cycles of warming and cooling in the Pacific Ocean. And we actually, if you take a look at this, this goes from about 1875-ish all the way to 2000, and you can see El Nino events, you can see La Nina events, and then you can see areas where we are neutral. The last thing we got to talk about and see is actually the Indian Ocean circulation. This is going to set up the monsoons. You can see the monsoonal drift there. But basically what it's made up of is the north and south equatorial currents. Hopefully you can see those, but the north current is there and the south current is here. It also has the equatorial countercurrent. It also has the Gulas current over here, which is flowing water to the south. It has the Antarctic circumpolar circulation, which is down here, the west wind drift, which is moving it towards the east. And then we have the Western Australian current, the WAC, not the EAC, which is over on this side, which is actually bringing cold water back up. So we got warm currents and we got cold currents, and we have basically this counterclockwise flow, which we expect to find in the southern hemisphere due to the Coriolis effect. And you also get what's called seasonal shifts in wind currents, and that is what the monsoon is. Monsoon does not mean rain, it does not mean dry, it just means a shift in weather patterns. And basically what we do is we get very dry areas up here, or we can get very wet areas here depending on the season. And that's what the next slide will show. The winter monsoon actually sets up so we get highs over here, and I'll give the explanation on the next section. But we get highs located up here on the Himalayan plateau. High brings air down to the surface and it flows out. And this actually brings dry air over India and Indonesia and into Africa. And this is the winter season. During the summer, we actually get a reverse where the wind's coming off the Indian Ocean onto these land masses, bringing moisture and rain, especially when it hits the Himalayan plateau and goes up, but basically causes lots of flooding. The reason that it is caused is by this intertropical convergence zone, which during the winter is found low, more or less in the middle of the Indian Ocean. And what that does is the air converges in it, so air comes off of the Asian landmass and actually comes in from Antarctica as well and converges there, which we get lots of rain. And then during the summer, it actually shifts, so it's actually up above India. So now we get air coming off the Himalayan plateau, but we also get air coming into or off of the Indian Ocean. It converges over these areas and causes lots of clouds and rain. And the reason we get that is because of the tilt of the Earth. If you take a look, this is the summer. For us, it's the winter basically for them, and it takes the convergent zone and it puts it down a little bit below, because it's going to be here, puts it below India. And then we get the same thing. We get this area right there, which is the convergence zone, and now it actually is located up above India and causes rain. And then here it is again, the high bringing dry air down, and the low bringing moist air off the Indian Ocean. And it's just basically this shift of wind, which is what's called the monsoon. We do have a dry monsoon and a wet monsoon. We have a winter monsoon and a summer monsoon. But we get these monsoons. They're also called, we have a monsoon in Arizona, which actually brings moisture into Arizona. But basically it's wind coming out of the Gulf of Mexico and the Strait of California, or we have the dry where it's coming off the rest of the North American continent. We can also get what are called Chinook winds up in Montana, Idaho, where the wind is actually shifting up and down, and even in California where it's shifting up and down mountain ranges, sometimes coming down, which brings dry, sometimes going up, which brings wet. But usually it's a dry wind anyway, and it can actually feed the fires that are out there. And then the last thing here is a picture of a wedding going on in the wet monsoon, which is actually their summer months, May through September. And if you take a look at it, it looks like they've got more water, but it looks like their life goes on because they're used to it. And that's where we are going to stop for 7C. Thanks for stopping by. Adios.